Hello, hello, hello. We are doing another web dev office hours, and today I wanted to start with something that I was working on earlier today. Let's see. Let's get the screen up so you can actually see what's going on. And over here, I just have this temporary file, and it's pretty common in JavaScript to create some sort of definitions map. So let's say something like const definitions equals, and we'll set that to an object, and we'll say something like A is sure, we can use that suggestion, and B is sure, why not? So we have an object called definitions, and we can call this something like, a function called get definition that takes a parameter or a letter and returns definitions at letters. Yeah, okay, cool. And then this is going to complain because I'm not calling it. And we can just say console log get definitions A, right? And this is an okay approach. Actually, this is a perfectly fine approach. It works well enough. Something that I've been dealing with lately is this is often referred to, this data structure is often referred to as a map, and an object can work just fine for a map, but it does have some limitations that can be improved on with a different data structure in JavaScript. So some of those limitations are that if you wanted to reference a value directly, that's a really quick lookup because this function is going to go to this definitions object and go straight to whatever the value is that we want. So in this case, the letter is being passed in, and we're grabbing the letter, which is the property here. And yeah, that works pretty well. But what happens if we wanted to loop over all of the items in this list of definitions? Well, then we'd have to do something like, let's see, function get letters. And we don't need to take a parameter. And yep, sure enough, we can also call that down here just so we don't have this red squiggly line yelling at us. And what getLetters does is it's going to use this object.keys method to loop over, well, essentially take this definitions object and return all of the properties on it. And I think that is kind of an awkward approach. Like if we wanted to loop over them and do something like get letters capitalized, right? I'm going to get rid of this thing. I don't need that. And I'll just do a quick little fix here and say, you can just disable for this line. Cool. Don't like those red squigglies. Don't like that either. Got a lot of auto formatting stuff going on. Cool. So what we might do here is return object.keys and then dot map, and then here we'll have the letter, and we'll return letter to uppercase. And I think the thing that kind of bothers me here is it feels like we're looping over this data twice, which with two items in that object may not be a big deal. But one thing that I like to play around with is when I'm working with these maps, instead of using an object, I will say that my definitions are actually going to be a new map, which is a constructor. It's that JavaScript makes available to us since a recent version of JavaScript, and we can instantiate it. It takes an iterable, I believe. And so one easy way to do kind of the equivalent of creating an object with key value pair is to create a map with key value pair. You can pass an array whose children are key value arrays. And the sort of benefit that we get here is we get something similar to the object where, but instead of referencing with bracket notation, we can say definitions dot get. And I guess technically it should be letter to lowercase, but we didn't do that in the previous example, so we won't do that here. To get one of the values based on the key, we use this get method and we pass in the letter that we want to use. And the nice thing, so that so far, pretty similar objects and maps. The nice thing about using maps is you can actually loop over them very, very easily. So we can say, I think my mouse just died on me, or it's dying. Let me plug that in. Better? Happy? Nice and fed? Cool. One thing that we can do is instead of doing this sort of thing, we can say like const letters equals, we want it to be an array, right? And a couple things that we can do is we can use a for loop. Definition.entries, I don't think I need. Well, what we can do is say definitions.ForEach. And right there, very easily, I think the ForEach having both a way to get a value directly or loop over each key value pair is pretty handy. So we can say for each item or key value pair in definitions, we can say letters push key to uppercase and then return the letters. Okay, this, yeah, okay. The my linter doesn't like that I'm using for each. Nonetheless, this is perfectly valid and this works, and it's a very intuitive way of looping over all of the keys and values in this map. That's something that's built into maps, which I personally really like. Where was I gonna go next? Let me see. Okay, so now a situation that we may find ourselves in is that we want to, for some reason, let's see. Well, I guess I'll do this other version where not only do we have access to this for each, but we can actually do a for loop over these this map, and you can grab the key and the value. And I think because we're just using the keys, we can just do that, and we can say letters dot push the key to uppercase, and that works just as well. So to me, this is a very intuitive and efficient approach at looping over the items in a map if we use the map constructor. Again, perfectly valid to use an object, but maps do have other advantages. So I'm not going to get entirely into that, but one of the key things is that objects can only have numbers or strings as their keys, and maps can use much more robust key identifiers. So worth checking that out, and the fact that you can both get an item directly and loop over all of the items very easily with a map. So where I was earlier today, though, was that I not only wanted to work with a map, but I wanted to have some type definitions that I was working with. So I like using JSDoc, and I was going to say that const, let's see, some key equals the letter A, right? And let's say another key equals the letter C. And I'm actually going to get rid of that. And boop, boop, boop. And we're going to, I need to disable that for the whole file, I think. Okay. Let's do a quick fix, entire file. Cool. Now it's not going to yell at me. So what I wanted to do was essentially create a new variable and say that the variable was only allowed to be one of the keys in this map. So with an object, that's easy enough. Let's say this is old definitions. I can come down here and you see that this can be A or C. It's pretty loosey-goosey. That's because right now it's a type of a string, or I guess it's a type of string A. I want to give this a new type definition. So I want to say that A can be anything, any of the keys of the object old definitions, right? And it's pretty happy to be that. Right now we can see that the definition can be either the string A or the string B because the properties are A and B. If we try and do the same for C, it is not complaining for some reason. And I'm really not sure why. Is my TypeScript compiler running correctly? Does this need to be type of? No. Well, that's embarrassing. That really should be working like that. Well, we'll continue. In any case, this, you can see that the type definition here is a union, meaning it can be either the letter A or the letter B, and we should be getting a red squiggly here when we try to assign it to the letter C. So that's if we're working with old definitions. Now, I ran into the issue where I wanted to do the same thing using a map, but a map does not play nicely with this key of utility tool in TypeScript. And so what it's going to say is, hey, this is actually not the letter A or the letter B. It's the key of map string string, which doesn't actually make a whole lot of sense. So in order to fix that with JS docs, we can get rid of that now. So I just want to jump in and I guess show that it's kind of easier to fix this. What we can do is pull out this variable and call it the, I don't know, map data. And we can say const map data equals reassign it to that value. And now that we've reassigned it to that value, this is thinking that it's a two-dimensional array of strings, which isn't super helpful because we want to actually show that the first value has to be either the letter A or the letter B. And to do that with JS docs, we can use this syntax, which is a terrible syntax, but in this case can be helpful. Is that we're actually going to inline assign this to a type of const, which is a constant in TypeScript. And one thing that we need to do to make that work is use this little parentheses, which is kind of weird, but doesn't actually functionally do anything. And that's const is undefined. That's interesting because that should totally work. Let me see. If we do new language, JavaScript, paste that in there. Huh. That's very strange. Okay, well, anyway, I'm not sure why this is working in this project or not working in this project. It was working earlier. Well, okay, I see what's going on. This is an ESLint problem, not an actual TypeScript problem. So it's because, oh, that's annoying. Disregard that problem. That little red squiggly is not a legitimate little red squiggly. So what we see here is the map data. Okay, so this is the important thing to see, is if we don't have this syntax, we can see that the map data type is an array of arrays of strings. Or in other words, an array of strings. By setting the type to constant here, a TypeScript constant, we're actually modifying the map data type to a read-only array with the first character A, which is a checkbox, and the second character B, which is the Unicode X character. That's not really super relevant. But the reason why that matters is because now our definitions map shows us that the first character or the keys are either the letter A or the letter B, which means that when we get down here and we don't want key of, we want, okay, this is where it gets kind of complicated. But we're going to create a new type called, I don't know, MapKey, right, to represent A and B. And what it's going to be is the type of map data at any index. So just any number. Could be 0, we would get this, could be the number 1, could be this. Regardless, it's going to be map data at the any index. And we just want the first character. So this is a little bit of TypeScript magic to say that we're creating a new type called MapKey, which is going to update based on whatever keys we have here. Why that's useful is because now we're saying that we want this to be a, map key, which means here, this one is okay because it's either A or B and it's the letter A. This one normally throws a little, I wonder if it's throwing an error because of that. Let me see if I can fix that. That's going to be in my ESLint file. It's complaining because JSDoc does not know anything about the const type. Close that. Oops. Open it again. Cool. That error is fixed. And it's still not showing our errors here. That's too bad. But normally, if you try to compile this, this is going to throw an error because we are assigning this to a character or assigning this to a value that it's not allowed to be. I can clear this all out too because we're not using that. And then the last thing is if we wanted to add a new key value pair to this map, because we are inferring the type here instead of saying that this is like type of, let's see, let's get rid of this guy and see what this looks like. This is going to be a type. It's going to be an array where the values of that array are another array with either the letter A or B or C. And the value is going to be a string. Cool. Yeah, ABC, that's fine. This is working as expected. And MapKey, we don't need to worry about. Don't need to worry about all this. What happens is, let's say if we wanted to update this, right? Let's do this. We could maybe have this like manual thing where a map key is either A, B, or C. This array is going to be an array of map keys to string, so map key ABC, and these are map keys, so it's either A or B or C, right? A or B or C. So the problem is that I've been trying to solve, that I solved today, is if we want to add a new value here, you're not going to help me out? Okay, cool. And we add a D, then we also have to come up here and say, well, this also can be the letter D, right? And now these are kind of working as intended. And if I decide, no, let's go back to just having A and B, this is now going to be invalid, and unless I come back here and fix this. So instead of having to maintain this information in two places, what we can do is go back to how it was, where we say this is actually going to be the type of, grab the type from the map data, which is apparently any, but it should be an array. And then right, because we don't want that. There you go. Map data is an array of, it's a two-dimensional array of strings. And then once again, we're going to grab the number and we're going to get the first character or the first item in that second array. And by updating that, our MapKey type is a string. By setting this to a type of const and wrapping it in a parentheses, now it's no longer an array of strings. Now it's no longer a string. It's only the letter A or B. We can easily update that by saying, well, it can also be C, and then we're only managing it in this location. So I hope that was clear. That was kind of a lot to go through, but it's pretty handy information because I personally don't like the maintenance stuff around TypeScript. I don't love this syntax either, but by doing things this way, I can maintain consistent typing with very, very little effort, which is cool. So that's it for that. Let's get into the project that we've been working on, which is the Worldle clone. So that's working, that's running. We have our project. We are going to get into our file. I made some changes. What did I change? I made a few changes. I don't know what I changed. Right. So what are we going to work on? Okay. I wanted to have this virtual keyboard work so you can actually click on it and have it update the data. So we're going to do a couple of things. We could approach this by adding a click event handler to all of these buttons. After all, they are all buttons. But if we do that, there are 26 characters, which means we're technically adding 26 different event handlers for each one. And that's really an unnecessary approach, because what we could do instead is actually come up to, let's say, this div, and we can put the event handler there. So let's go that's view again. On click is going to be handle click is fine. And way up here, we have our change event handler, and we have our click event handler. And we're going to grab the event off of that. And we are going to say, how about we just console log event, right? And so what happens with this in place? Let's see, we've got our console. And now when I click on any of these buttons with a single event handler, I'm getting all of those click events for every one of those buttons, which is very cool. The one issue is, let's see, the event target. The one issue is if I zoom in really close so we can see this, and I come down and I clear this out, I can still click on these gap areas. And that's going to actually be clicking on the unordered list, which is the row. And we don't want that. So what we can do is, am I back to reset? Is we can check the event target, and we can see what the tag is by checking the node name. I think I want the local name. Yeah, we'll get the local name. So we'll say if the event dot target dot local name, and I'm going to update this to make this a little bit easier for me, and say that the parameter is a, do I have click event available or just event? Ooh. Can I do a click event? No, just an event. Mouse event. Pointer event. No. I'm going to stick with just an event. Missing param event. That's going to be the event. That's fixed now. So now, because that is an event, I think I can actually get some IntelliSense on here. Event target dot local name. No, it's still not telling me that. If the event target does not equal local name, I'm just going to return early so that the rest of the body of this function doesn't run. And now that we are targeting just the buttons, we can do this zoom thing again. And we can reload, and I can see if I click a button, I see that synthetic event. But if I click outside, that's something that's not a button, I'm not getting that synthetic event. So the next thing we can do is actually update our word and set current guess. So we're going to look at the current guess. So if current guess dot length equals 5, we're also going to return because we don't want to make the word longer than 5 characters. Otherwise, we're going to set the current guess equals basically what it's saying here. I'm going to pull this out into the letter, and I'm going to say const letter equals event target inner text. And if that works correctly, then prefer text content. Okay, sure. I do whatever the robots tell me to do. Okay, so we can reset here, and we can reset our screen size. This can be fine. That should work. And if we change what the current guess is and we log what the current guess is, and then if we click on one of these, we can see for some reason our logging is not working, but we are updating the current letters in there. So that's pretty handy. So why is it not logging then? I don't know. And I think I'm actually going to change this so that one other thing I want to do is say I want to add a delete button or an enter button key and a delete key. And we'll add those. Where would they go? Let's see. Not in our remaining guesses, not in our form, somewhere in our list. So we've got our unordered list. Now we've got a few unordered lists that we're mapping over. And then I guess at the so we can do this a number of ways. And I think what I want to do is essentially add the buttons at the very end of the list. So we're going to say for the last item in the list, let's see, here we're looping over each letter. And so here we want to say if the current index, which is going to be the index of rows, and that should be like that. So if the index equals the keyboard length -1, which is going to be the last item in the last row in the list, then I want to add another list item. I want to add 2. This one's going to be delete. This one's going to be enter. And then we close off that logic. And we add some class names. The status there I no longer need, but I might want that later. Class name here goes on these list items. And we need some classes for our buttons. It's just going to be the background gray. Class name is key and background gray. So button class name equals key and background gray. Cool. Save that. That should auto format some of that stuff for me. That should auto format some of that stuff for me. Ah, React fragment. Can't have two elements in there. So I need this guy and that guy. I need a little fragment in there. Did actually I get in there? Come on. Okay, we have our one element. We have ESLint thinking about it. We've got that formatted. And there we go. So now we've got our elements. The delete key and the enter key don't have the right sizing because I have a hard-coded block size, and that should probably be min block size. Oh, block size, wrong thing. Min inline size. That's looking better. Let's go to our class, our student styles. The key down here should be min inline size, not size. And your min inline size. And this is looking pretty good now. Now we've got the enter and the delete key. The problem that we have obviously is when we click the enter or the delete key, we are filling in the data that's not supposed to be there. So I want to change how these letters are working. So instead of the data status, I want the data key to be the letter key. And down here, I want your data key and your data key to be, this one's going to be, which one is this? Delete. I call that delete. And this one is going to be enter. And in our event handler, you can probably guess what I'm going to be doing next. We're not logging. We're going to grab the event target, no longer the text content, but the data set. This is not correct. Let me see. MDN click event. The mouse event. I guess it must be a mouse event. So let's try that. Mouse event should give me a event target with, HTML element it should be. Well, easy enough to fix. We'll say the element equals the event target. That's going to be a type of HTML element, which means is the element dot data set. That is helpful. Thank you very much. And the data set is going to be the letter. And then we're going to say if the letter equals delete, we want to set the current guess to yat. That looks right. Else if the letter equals not space, but enter. Then we want to submit the event, right? So we need to grab the form and actually submit it, which I think means I'm going to need a ref. So let's finish out this part. Else, and we'll just say console log submit the form. Okay, cool. So if we say oh, undefined, awesome. Oh, that's because it's not letter, it's the key. Dataset is the key. And I guess instead of that, we're going to do key. And that should reset here any moment. If we say HEAB, oops, and we say delete, we actually wanted that to be an R. And if we hit enter, we want to submit the form. So we have one problem there. And this is actually going to be kind of cool. I can do this with JavaScript, or I can actually use HTML to accomplish this. And one thing I want to check is if our form, which is somewhere between here, if our form is not visually hidden, it's getting that. So I'm actually, what? Oh, did I turn off the... Yeah, I turned off the form's validation. I don't think the form's validation is turned off. Input is required, minimum length of 5. I shouldn't be able to submit. And if I type here, oh shoot, I should be able to submit that. But if I do that, yeah, I should not be able to submit. And if I type something else and I submit, that's not right. Well, that might be a React thing. Nonetheless, we'll move forward. We can do this. If the key is enter and the current guess length equals 5, then we can submit the form. And we can do that very easily with HTML, I believe. So I can say that this button's form equals I don't know. What would I call that? This buttons form is going to be called the guess. And the way we connect it to our form now is by giving this form an ID of guess. So now it is submitting our form as we expected. And the only thing we need to do is actually account for this. We don't want that to be the same because if it's the enter key, we always want to step into this logic box here. And we want to say if the current thing is, if the length is less than 5, we want to prevent the default behavior. That's going to prevent it from submitting the form. Otherwise, we're going to go ahead and submit the form. That was some pretty easy logic to deal with. And let's go back. If I hit enter, nothing happens. If I type 4 things and hit enter, nothing happens. If I type the 5th one and I hit enter, our form submits. That's pretty cool. It's not a real word, but that's pretty cool. And we've got some things to play around with here. So ENT, ER. How about what's something that we can guess that ends with ER? How about, I don't know. I'm not going to worry about it. Cool. Delete doesn't do anything unless I have some letters, so that's pretty cool. This is looking pretty good. Now, the only thing that I want to change is I'm going to actually place the enter and delete key in their correct corresponding spots. So enter should be on the bottom left. So that's easy enough to do. I'm actually going to move the enter key up above the delete key, but I'm going to keep them here so that they're technically at the end of the board, like this. And the reason why I'll explain in a moment. But in my CSS, I'm going to say, let's see. I forget the value, but it should be like position. No. Flex. Let's see. It should be like flex position. Order. Order is what I want. I want this to be order of, no, not that one. This, the list item, to be order of 1 or 0. No, -1. That's it. So in order to put the button first, let's go up to our flex stuff in case we would ever want to use this again. And we'll just do a class of negative order 1, which is going to be an order of -1. Go to our buttons. This list item with the enter is going to be have the class of negative order 1. And with that in place, cool. The layout is correct. We have the enter key at the bottom left visually and the delete key at the bottom right visually. But very importantly, if we do the keyboard navigation and we go through our list of keys, when we get to the end of the second row, we don't want to go to the enter key because that's kind of logically out of place. And by putting it in the DOM at the end of the list after the letter M, we can actually maintain that sort of tab order that we would expect, where from the letter L it goes to Z, X, C, and then only after M does it get to enter and then to delete. So that's a really easy way. If you want to maintain tab order, then you can do that with some flex. Just make sure everything's in order in the DOM that makes sense, and then you can use some flex or grid order properties to place it where it belongs visually. Oh, hey, sorry folks, I just noticed that y'all were here. Justure or Yoast. Why is it spelled Worldle? I don't think it's spelled that, so I'm spelling it Wordle because it's a clone. And I don't know, we're just building it for fun. I'm not going to actually use it or publish it or anything. Yeah, because it sounds the same, but it's kind of a clone of the game Wordle. And Omri, what's going on? Good to have you back. I was hoping that you would show up because we talked about some interesting stuff here with the CSS flex layout stuff. So I'm going to jump back through it and do a little recap of what we covered this week. So let's see. We got a lot of code. It's all in one component, which is fine. So let's see. What did we cover that was cool? So today, the things that we played around with was this idea of event delegation. Yeah, I was hoping you'd show up because we covered some cool stuff around like laying out this grid in a semantic and also visual layout way, which I'll go back through. Well, I'll just cover everything that we went through right now. So one of the things that we covered earlier was these keyboard events where we want to add an event listener for all of the buttons in this keyboard. Oh no, my delete button broke. Oh, I see the problem. We can't delete if we put in 5 characters. Okay, this is not going to work. This is easy to fix. We just say that hit save, and that's it. Cool. That should be fixed. That is not fixed. If the length does not equal 5, or if it is, less than 5. Less than 5. Less than 5? I think that's right. So we type in a bunch of things. The delete key can delete stuff, and we can keep typing in. Cool. Okay, so what did we cover today was looking at this big like virtual keyboard that we've built. We want to have an event listener that listens to all of these events and updates our current state or does a reaction to those buttons. So one approach that you might take is having the event listener on every individual button, which works fine. But we have 28 buttons here, and we probably don't want to do that. Or another approach that we can do is instead of putting the event listener on every individual button, we can have a single event listener on the entire keyboard. So here's our keyboard, and we put the click handler on the keyboard element. And the advantage there is that this pattern is called event delegation, is that now all of the same handler, the single event handler that we're adding, is handling all of the events. And why that's an advantage is because it preserves some memory. If somehow if this list of characters or buttons was dynamic, meaning we're constantly adding and removing buttons to and from the DOM, we don't have to add event listeners and remove event listeners from those elements. It's a good approach for memory management. So we just add one listener to the root. And how does that impact event target? So when we add an event listener to each individual button, it makes it really easy to capture the event listener's target and grab that button consistently. The problem with the event delegation approach is that we don't always know which element we're clicking. So as I showed that earlier, if I zoom way in and I click here in this gap, I'm technically on this unordered list, which is inside of our keyboard. And the event listener is still going to fire on that unordered list. And the event listener is also going to fire on that div. And we don't really care about clicks on the div or on the unordered list. We just care, or this list item, we just care about the clicks that happen on the button inside of that list. So quite easy. We basically just grab the event target and I'm actually going to refactor this, move that up there, and then we're going to say the element, if the element's local name is not button, then we can just bail early on this event handler. So if we click on the div, we don't care. If we click on the list item, we don't care. If we click on the unordered list, we don't care. If we click on one of the buttons, okay, let's get to work. Let's grab the key from the button's data set. So on each button, we are adding the data-key attribute, and we're just assigning that to the letters key, which I probably have this logic backwards. This should be key, and this should be letter, but that's fine. And then on the enter and delete key, we're also adding a data key attribute, one for enter and one for delete. So if we go back up to our click handler, we can check for the delete key, or if it's the enter key, or in any other case, we can update the current guess. So what is local name? Local name is a property from the DOM. So let's see. I want to reset that. I'm going to go to my console. I'm just going to grab any element here and copy that as where was it? Store as global variable. And then cool, we've got this temp1 variable. And if I say temp1 dot local name, it's going to return the tag name for that element. So here, because I grabbed this span, it's going to return span. When I'm on another DOM node that's a button, it's going to return button. If I'm on a DOM node that's a div, it's going to return div. So that's pretty handy. Some of the other things that we covered this week. Let's see. Oh, the other thing we covered today that was cool is we got our virtual keyboard in place, and we did a little bit of manipulating with the flex grid order. So if I tab through my keyboard, I can go through the top row, and then at the end of the top row, if I tab again, I'll go to the first element in the next row. And if I go to the end of the second row and I tab again, because we're in a virtual keyboard, it would not make sense to go to this enter key. So what I actually want is to go to the first letter of the next row. And we do have that set up. And then if we get to the end of the letters in the second row, then I want to go to the enter and the delete key. And we do have that working as well. And the way that we set that up was essentially by just sticking to what the DOM does best, which is we have our list of rows as separate unordered lists, which may or may make better sense as a single list with separators, but that's fine. We have different unordered lists for each row. And in the last row, we have all of the characters in the last row, but we start, the very first character is the letter Z. And the last, well, not the last character, but the third to last character is the letter M. So we put all of our letters first. And then after the letters, we add the enter key and the delete key. And because that's the order in the DOM, that's why it makes it easy to tab through and go to the letter Z first, and then all the way back down to the end of the list to the letter M, and then to the enter key, and then to the delete key. It's just following the order that they're placed in the DOM. Now, in order to get the enter key in a different position visually, we know that the unordered list that's wrapping everything is a flex container. And inside of flex container, we can play around with the order of elements using the order property. So here, this enter key or the list item surrounding the enter key has an order of -1, which means it's going to be, well, assuming that there's no other things going on with other list items and their order, it's going to be the first item in the list, or visually the first item in the list. And there, you can go negative, you can go positive, you can ensure that an item is the last item in the list by constantly giving it a higher positive number. And that is the cool thing about that. We are using the natural order of the DOM and a little bit of flex magic to change how things look, but maintain a good keyboard user experience. Next, the other thing that I wanted to focus on was something that we covered earlier this week, is getting a layout for this keyboard. In fact, I thought was kind of interesting. So when we're looking at different ways to lay out content, CSS Grid is super handy because, for example, it lets us create these different rows and columns, and as long as everything lines up, we can just keep using Grid to make these this experience where rows and columns line up. Now, that doesn't make sense in a keyboard layout because obviously we have different rows or different columns for the first row, but those columns don't align with the second row. So in order to accomplish that, we can use a combination of CSS Grid and Flexbox. We can use the grid on the entire keyboard to make it kind of an easy experience of centering content and also having a gap between it. So this entire keyboard is a grid element with a gap of 4. That makes sure that each row of the keyboard has a gap of 4 pixels in between. And because we're justifying content to the center, all of the grid or all of the nested rows inside are going to be justified to the center. Now, we want the individual keys to kind of, or the rows of keys to kind of like line up the same way as they do on a keyboard. So we're not really caring about what the other rows are doing. We just want them to kind of like flex into the space that they have. And that's why instead of a grid, we can use a flex container and justify the content there to the center as well to make sure everything just squishes in. And yeah, it's a really cool combination of CSS Grid and Flexbox to make sure that the spacing is good. Of course, we probably didn't need to use the grid at all. Let's see, if we undo that, Then the only challenge here, it's really Flex doing most of the work to get the keyboard to look right. The only reason why we use grid is so that we're not trying to manage the spacing between elements on every single list item. We can kind of do that from the parent by setting it to grid and giving it a gap. So that was a cool thing. We can do the spacing with Flex on the parent too. Yeah, we could. We totally could. We could say, let's see, instead of that being having any styles, we can say that the element style is a display of flex, and then we can say that the flex direction is a column, and then we can say that the gap is once again 4 pixels. We could do that. Or instead of using this flex direction, we could just say that the display is grid. And then it's a single column grid. So everything just stacks, and it's kind of a little bit shorter. I guess we really don't need the justify content center on that. So let's take that out. Let's see. Doop. Right, because the justify center just needs to be on the rows. And that's pretty cool. I think that's, let's see. No, I think we covered a couple other things. So another cool thing that we covered this week was we actually got the logic for the wins and losses and for bad words or invalid words. So here, if I type an invalid word and I try to submit it with the form, we're going to be flashing this message that says, hey, that's not a word. And the way that we're doing that is using remix sessions. So if I go to the root, and in our logic for when the form is submitted, we can say here, if the list of all 5-letter words does not include whatever the current guess is, which is what was submitted through the form, then we can use this session.flash method to send an error message that says, hey, that's not a valid word. And then on the front end, we can basically use Remix to grab the session information in the loader, which is going to run again both on the server side and on the client side. So that when that loader runs, we can grab the session and we can say, we can check if that session has this error message, and then we can return that data as part of our loader's data as a JSON object. That's going to run server side, client side, like I mentioned. And then when we actually get the component, we're going to grab the data from this use loader data hook. We're going to grab the error message off of that, and then we can check if that error message exists, and if it does, we can show it. And otherwise, we don't have to do anything about that. So that is how we are using this. We are showing this flash. And the cool thing about the flash is that it's called a flash because it only runs once. So if I send invalid data, it's going to run once. And if I reload, that flash message is gone. So that's really handy for mostly like validation stuff, is when you would want to submit some data and then return that flash message. So yeah, it was a pretty productive week, and I'm quite happy with the results. I think this is going to be the end of it. So yeah, unless we can think of something else, which really it's mostly feature complete. We could do things like adding the statistics tracking or whatever else we want, really. But for the most part, we got to play with some cool remix stuff. We got to play with some cool React stuff. We got to play with some cool CSS stuff. And we got to play with some cool like native HTML stuff. Oh, one more cool thing that we did was this enter key. if I want to say like puppy and submit this data, I can hit enter and submit it. And the way that this works is actually not using really much JavaScript. This is using just built-in HTML primitives. So this button for the enter key has a form attribute attached to it, and the form's value is guess, which allows us to attach that button to the form through the ID. So it essentially lets us put a submit button for the form outside anywhere else on the page. And so by doing that, it means that as we, put all this data in and we want to submit the form, hitting this enter is actually going to submit the form, and then all of the logic around how the form is submitted is then taken over by HTML and Remix. So that's pretty cool. And I think one last thing I want to play with before we call this a close is Remix has a form element, I believe, or a form component. And I want to see what it does because I think it's actually a little bit different. Forward ref exotic component. Cool. I feel like with that in place, I wonder if it's going to make the request to the backend or not. So let's say, let's go to our form and say tests. And if I submit, cool. Okay, that's awesome. What happened there? Let's reload the page and I say tests and I hit submit. A big ol' nothing happened. Okay, not so awesome actually. Uncaught in promise error routes index does not have an action, but you're trying to submit to it. Okay, so there's a little bit of a bug on Remix end, and that is that when I submit this form, when it's an HTML form, it will submit to the root action. But when I submit with this form component, it will try and submit to this components action. So I think what I'm going to do is I'm going to grab this action out of here. And then I'm going to put, let's see, the loader, the word of the day is fine there, I guess. It's been working fine. I'm going to move the action in here. Redirect and all words needs to come in. So redirect and all words. Okay. So our redirect should be working. And now because this is being exported here, I think I should be able to actually import it. So we don't need that anymore. And we can import action from our routes/index.jsx. That should give me my action here. And then that can actually be export import action. I think that's not the right syntax. I think I can just do this. Export action from there. Cool. So that should handle the HTML way of doing it. Let's see if that's right. Our form here, we undo that to just form. See if we didn't break anything. All right, ESLint, you are taking a long time. Okay, that's going to rebuild. That's going to reload. We have our form. We say tests, and it looks like our action is still working. Yeah. And then if I change that to, oops, if I change this form to uppercase form, and we pick something, we say snout, and we submit. Okay, cool. So this is the cool thing that I wanted to see. This is what Remix is going to kind of do for me with this component. Is if you can see here, my page is not reloading anymore when I use this form component, and Remix just kind of handles that for me and updates all of the data. So the only thing that I need to do is really reset my current guess, because I don't want that to show there. So that's a nice handy way to have a little bit of different, better user experience, because we're not relying on a reload, and Remix just handles the rest. That's really awesome. Let's see, if I reload and I type a bunch of stuff here, and I clear out my network requests, and then I submit my form, I don't think the page reloaded. It just gave me the data back. So that's pretty cool. I'd have to figure out how to clear this out. But we're already over time, so I'm going to call it. That's the end of this stream. That's the end of this series. I'm going to move on to a different project tomorrow, or I guess Monday. So if you like this, please share it. Let people know. Feel free to stop by and bring some questions, and I'll be happy to answer those. And yeah, I hope that this was cool and enjoyable. It was a lot of fun for me. So thanks. I'll see you.